Okay, business algebra 8.4 puts us in some actual scenarios with probability and to see how we should handle them. So remember that the number in the union of two sets is the number in each set minus the number in the intersection. So the addition rule of probability says the same thing. The probability of two events occurring, one or the other, is the probability of each event occurring minus the probability that they both occur at the same time for the same reason. So when playing American roulette, the croupier spins a marble that lands in one of the 38 slots in a revolving turntable. The slots are numbered 1 to 36, with two additional slots labeled 0 and 00 that are green. Consider the number 0 and 00 as neither even nor odd. Half the remaining slots are colored red and half are black. Assuming a single spin of the roulette wheel is made, find the probability of the marble landing on either a red or an even number. Okay, so we'll assume that, say, 1 through 18 is red and 19 through 36 is black. Okay, so we have to take the probability of each event occurring individually minus the probability of both happening at the same time. So we know that 18 of the 38 are red. Sorry, 16 of the 38 are red. And we know, well, it's 18. I'm going crazy. 18 out of the 38, because half the numbers are red. And then it wants to know the probability or even. Half of 36 is 18, so another 18 out of 38 are even. However, if 1 through 18 is red, for example, that means 2, 4, 6, 8, 10, 12, 14, 16, and 18 are both red and even, so I counted them twice. So we have to subtract them off. So that's 36 minus 9, which is 27 out of 38, which you can get as a decimal form. Should be somewhere around 0.7. We'll put it in. If you don't have a calculator, you can put it in Google for the time being. 0.711, rounding to 3 decimal places. So a pair of 2 dice are rolled, a pair of dice. The outcomes are shown to the right. So here's a picture of all the possible outcomes, the 36 outcomes. What are the chances that the first shows a 2 or the total of the rolls is 6, 7, or 8? So the first roll shows a 2. There are 6 of those out of the 36 total. The totals are 6, 7, or 8. Totals are in the diagonals. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So plus 16 out of 36. Now, if anything I counted twice things that are both first roll is a 2, and they add to 6, 7, or 8. That would be the 2, 4, the 2, 5, and the 2, 6. So I actually have to subtract 3 out of 36. 6 plus 16 is 22, minus 3 is 19. So 19 out of 36 is approximately, as a decimal, I don't care if you do fraction or decimal, but your homework may tell you, about 0.528. The sum of both dice is 11, or the second roll is a 5. So the sum of the dice being 11 is here, 6, 5, and 5, 6. That's 2 out of 36. Second roll being a 5 is 6 out of 36. That's this column. But the 6, 5, I counted twice, so I have to subtract 1. This is 7 out of 36, which is approximately 0.194. Okay. This is how we apply probability, or some of our rules to probability. The complement rule. The probability of A complement is 1 minus the probability of A. So according to a recent survey, the probability that a male was a driver in a fatal car accident was 0.4. The probability the driver was 24 or younger was 0.3. The probability that it was a male under the age of 24 is 0.12. Find the following. So I would always suggest using a Venn diagram on this. We have male and young. The fact that it was male, we work from the inside out, so male and under the age of 24 is 0.12. That's the center. Now the chance that they were younger than 24 was 0.3. But 0.12 of that is taken up in the middle, so that leaves only 0.3 minus 0.12, which is 0.18. On the younger side, similarly for the male, 0.12 is taken up in the middle, so that means 0.4 minus 0.12 or 0.28 is over here. And that leaves the area on the outside to make up the rest of the 1. So when I add these all together, I get 0.58, so that leaves 0.42 out here. So what is the probability that they're male or young or both? That's the sum of everything in the middle. That's the 0.58 from the Venn diagram. The probability that they were not male or they were young. So young is this circle. The thing that gets included in the not male is the 0.42 on the outside. So that's everything but this crescent up here for just male and not young. So 0.42 plus the 0.3 is 0.72. What is the probability they were male and not young? So these two are opposites. Male and not young means it has to be both. So it has to be in the male circle, but not in the young circle, which is the 0.28. Not male or not young or both. So that's everything but the young males, everything plus but the 0.12. So that's the 0.42 plus the 0.28 plus the 0.18. Because these people are not male and not young. These ones are male but not young, which is fine. It's one or the other. And these ones are young but not male. So when you add this up, it's 0.88. So sometimes the Venn diagram can really help in this case. So one thing that's different about odds versus probability is the odds for something to happen is the number of successes to the number of failures instead of total. The odds against something happening is the number of failures to the number of successes. So 3 red marbles, 5 blue marbles, and 7 green marbles. You pull 1 marble, find the odds in favor of drawing a green. So the number of ways you can succeed at drawing a green is 7. The number of ways you can fail to draw a green is if you draw either a red or a blue. 3 plus 5 is 8. So when it's in favor of, it's successes to failures. Against is failures to successes. So against drawing the blues, how many ways can you fail to draw a blue? 7 red or 7 green or 3 red is 10. How many ways can you succeed? 5. But you still can reduce. So this reduces to 2 to 1. So your odds against drawing a blue are 2 to 1. Odds in favor of drawing a green are 7 to 8. And now we can do all of this stuff from a table, which sometimes makes it easier. In the above table, 96 people were surveyed. If one is randomly selected, find the probability the following is a female Republican. So that means female and Republican. And if we see where those cross, there's 17 out of the 96 total. You can turn this into a decimal as needed. We'll just do the fraction here. What's the probability they were a male? So the total number of males needs to be in the total cross male column, so that's 51 out of 96. A Democrat needs to be in the total of the Democrats column, which is 50 out of 96. So this is where it gets tricky and we have to use our rules. A male or Republican. If you notice, if we count the total number of males, 51, and the total number of Republicans, 46, that's 97, which is more than the total number of people. And that's because I would have counted the male Republicans twice, so I have to subtract them off. So we have 51 over 96 plus 46 over 96 minus the 29 over 96, the male Republicans that I would have overcounted in this case to get 68 over 96. Not a male Republican would be 1 minus those 29 over 96 male Republicans, which is 67 over 96. A male or a female, those two don't overlap, so if we had 51 over 96 plus 45 over 96, that's 96 over 96, which is 1. Of course, everyone in the survey is either male or female according to the listing. And what about an independent? So this is a certainty, and there's no independents listed, so 0 out of 96, which is 0, which is an impossibility. So this is kind of how it works from a table by comparison. And that's really all there is in 8.4.